you could put your friend graph on chain, and then you could maybe secure it through some privacy tools, and then also leverage it as data sovereignty sort of a situation where you only let people have access when you want them to have access, right? So you get to control the data. But
take the first step towards online privacy. Get NordVPN.
The Keystone wallet is the wallet that you want to be using to keep your crypto safe. Whether you are a Bitcoin maxi or an altcoin lover, it is perfect for you. Easy to use, 3 secure elements, and integrates easily with MetaMask, Kepler, and dozens of other extension wallets. Get one now to keep your crypto safe and secure. Go to bit.ly/CryptoRichKeystone. Hey Freaknik, hey Clayton, thank you so much guys for agreeing to do this. Clayton, you are from Lithium. And I did a video with you a couple of weeks ago. Your new layer 1 project. And Freaknik, you are with Melee and MathNode, and you've white labeled the Sentinel decentralized VPN. I've done quite a few videos with you, and I thought it'd be a great idea to put both of you together to find out about each other the project. Do you want to say just in a couple of sentences, each of you, what is your project, and then you guys can start taking it away. Clayton.
Yeah, so layer 1 is a new layer 1. Sorry, Lithium is a new layer 1 with a type of consensus we call proof of performance that we think can solve the scalability problem without compromising and deliver decentralized access to everyone in the world to use multiple times per day. Basically, long story short, as it gets more secure, it also scales because we incentivize people to deploy not just hardware that's difficult for the sake of being difficult, but actually has a use to run the rest of the blockchain, what the RPC nodes typically do. We're in testnet now. Phase 1, phase 2 coming soon, mainnet on the horizon.
Yes, I think later in the year, isn't it? Mainnet, that's the game. No?
That's the goal.
That's the goal, right? But it might get delayed, right? Okay. Freaknik, a little bit about yourself and your project.
So we are a white label on the Sentinel network, which is a Cosmos layer 1 chain that specializes in decentralized private infrastructure, public infrastructure, or DPIN. Our white label is Mela, which is a DVPN application that uses the community-hosted nodes on Sentinel to provide private, virtual private network, or decentralized virtual private network (DVPN) to anybody that uses our services. And Sentinel also has a decentralized AI network where it's an AI data layer that they can scrape any website and fetch information through a host of decentralized nodes that scrape for AI to train agents and things like that.
Well, that's incredible. That's a new thing. I didn't know about
cool.
that. Yeah. Clayton, what happened was when I was recording with you, we started talking offline about DVPN, and you got interested. So do you want to start asking what is it you want to know about DVPN?
Yeah, sure. I'm a VPN user, and I'm obviously I would say it's ripe for decentralization sort of application, right? Like there's a trust issue there with a VPN, right? Like I don't know if they're logging my data or what, or who may be sort of pulling the strings at these companies. But I guess my biggest question is how do you actually measure the decentralization in a way, or to put more simply, if I were to purchase access to DVPN for like a month, how does the network actually know that somebody's providing me that service? How do you
with any decentralized system, like say even Akash, which is decentralized compute, you have these community hosted nodes. So you kind of have a reliability issue that could crop up, like whether or not the nodes go offline and how fast the administrators respond and get them back online, or even if the nodes disappear, right? So you do have that kind of little bottleneck in the decentralized world where, maybe somebody didn't think their node was providing enough income, and so they canceled it while maybe some users subscribed during that month. So maybe a user only got 15 days out of 30. But we I think when you're using community-hosted nodes and decentralized networks, you have to provide some kind of quality of service reliability for users. So one way we do that in our white label is we have user feedback ratings. So every time you connect to a node and then disconnect, you can submit a rating, right? So how was the service? Was it fast? Was it slow? Was it did it allow you to access all the websites, or was anything geo-blocked? And also another thing we have in Mela is something called the node formula. So this is a a formula I derived mathematically. It's just an algebraic equation that takes in several factors. So it takes in the amount of time that it's been on the Sentinel blockchain. So when it was first registered on the blockchain. So if it's 6 months or 12 months that it's been active on the network, it has a higher score for the longer duration that it's been on. It measures the uptime as a percent. So 20% of the formula is based on uptime. So we have scripts that measure all the nodes on the Sentinel network and connect to the DVPN service and see if it's up or down at that time, and it gets a plus or minus based on uptime. It also factors in user submitted ratings and then like ASN quality. So ASN is like your IP organization. So if it's a residential node hosted on an ISP or if it's a data center node. So this node formula is based out of 100, and it goes from 0 to 100, and usually you're looking for a score somewhere around 75 to 100, and that means that it's been on the Sentinel blockchain for a long time, so it is garnered to continue support. It has a high user feedback rating, and it has a high uptime. So with decentralized computer, decentralized or DPIN networks, you need kind of a quality of service rating to be able to select the nodes that if you subscribe for 30 days, you're going to get those 30-day service. But also the thing that the modular approach to Sentinel is that if you subscribe for 30 days, to a node, and it goes off in 15 days, you can unsubscribe and get the remaining of your coins back. So that's an also really nice feature for users that the node went offline or it's been offline too long. They can unsubscribe and get the remainder of their coins back.
That's pretty cool. And Clayton, before you go to the next question, one of the things I want people to know who aren't familiar with VPNs and DVPNs, it's really, really important to use something. What a VPN does is it encrypts the data coming into your computer, and it encrypts the data going out of your computer or your mobile phone. So then it makes it really difficult for you to be spied upon. And the problem with traditional VPNs is that they're centralized. So just like the problems that we have with centralized banks and centralized money, you're subject to the whims of a third party. There's counterparty risk. With a decentralized VPN, what happens with Sentinel or any of the white labels is you can run the application from your laptop and earn cryptocurrency for doing so. And what you're doing is you're providing data, bandwidth, to the decentralized network. So instead of the encrypted data going to centralized servers controlled by one company, the data is being encrypted and hopping from laptops all over the world, laptops or computers all over the world. So there's no single point of failure. And like with Bitcoin, there's no single point of failure, and that makes it robust. Is that a fair description of how Sentinel protocol works? I should really know by now.
Yeah, we've done quite a few videos, but no, yeah, that's exactly how it works. There's no central authority controlling all the exit nodes, right?
Yeah.
So it becomes very, very, very hard for countries like China, Russia, or Iran to censor all the nodes because people are always the amount of nodes are always changing. They're always fluctuating up and down because new people come in and host nodes either from their house, which is pretty ballsy, but still it provides a whole new application layer when people provide residential nodes because it changes the whole IP intelligence services that are used for geo-blocking and all that. But yeah, that you got it spot on, Rich.
Thank you. Clayton, anything else you want to know about DVPN or questions that you think people might be interested in generally, but also for yourself as a potential user? We don't mind if he starts using DVPN, do we, Freaknik?
Yeah, I guess one comment would not really a question, but a comment was, I didn't realize it was multi-hop like that. So that's a little bit more like a tour.
Well, no, it's not multi-hop. It's not multi-hop, okay. Actually. It's single exit node. We've had multi-hop in the queue for a long time to get that, but the problem with the multi-hop is the payment structure. So since Sentinel it's not a privacy blockchain like say Monero or something, so all the transactions are available on a block explorer, right? So the payment structure is hard because you don't want, if you're doing a multi-hop, you don't want the payment to reflect what a wallet is connected, what nodes it's connecting to. Otherwise, it's kind of defeats the purpose, right? So So we are my white label is personally working on a multi-hop where the first node will be our own nodes that we host, and then so it'll go through that, and then any other secondary node that you can choose from the entire network will connect through from the first node. So it will mask the user's IP to the exit node. So we're working on that. We hope to
I
have
see.
something out by the end of the year. But yeah, right now it's just single hop.
And,
Okay.
and just on privacy, is Sentinel integrating Pirate Chain? Like you can buy the service using R?
Yeah, so we just finished that last week. It was a long journey. I spent about 18 months trying to implement our pirate chain into Mela. I went through their BTC Pay plugin fork and couldn't get that working because I'm not really a good Rust coder. I'm rusty on Rust. So, but we finally got it implemented. I created my own payment gateway on a weekend, and I got it, and everything worked flawlessly. So I was really excited for that. Yeah.
Wow. So then people can use the most supreme private cryptocurrency of all, and I am one of the crew at Pirate Chain, to purchase a privacy-focused decentralized VPN, thus compounding the privacy that's available. Clayton, anything else you want to ask?
Yeah, one more thing actually. So I guess it's Cosmos ecosystem, and I'm wondering if there's any feeling of constraint that you can't put as much data on chain as you would like to, and also I'm wondering, do you have to run an RPC node in order to, get information about the payments that were made and the services being provided, and what does that cost you, and how does that infrastructure play out?
So there's actually you do have to run an RPC node to query the blockchain, right? So nodes have to the decentralized VPN nodes connect to an RPC to submit transactions. There's transactions submitted like every 30 minutes to update the node status on the blockchain,
Hmm.
whether or not it's active or how much data has been consumed by a peer. And so
Would it be
all
helpful
the
if that was
nodes.
like every minute instead of every 30 minutes?
So when a peer disconnects, it automatically updates the blockchain instantly, right when a peer disconnects.
Okay.
But I think right now it's 30 minutes that it updates the chain with like how much data has been consumed in that 30 minutes by the peer, and updates it that way. So I think it's every 30 minutes. It makes a status update, and then if like Mela to subscribe to a node, it connects to a gRPC.
Mhm.
So it submits the transactions that way, and to connect to a node, it has to submit a session transaction. So create a session with the DVPN node, and then register that session and get credentials from the node, and then they can talk to each other.
Okay. And you're running the the Cosmos RPC node is run by not by the nodes, the VPN providers themselves. There's a single node that's run by the project. Is that right?
There's like 20
A bunch
different
of nodes.
RPCs. Yeah.
Oh,
So
okay. Okay.
we there was at one point last year there was a way we were going to look at a way to incentivize RPC nodes. Um,
Hmm.
but that's kind of been
Right.
put on the back burner right now. It's a
I
little
see.
tricky, yeah. But right
I'm
now,
aware.
publicly hosted by the community, there's about 20 or so RPC nodes.
Okay. The reason I'm asking about this
Clayton,
is
before you go on,
because
sorry, Clayton, before you go on,
yeah,
right? Because I'm sitting
go
here
ahead, go ahead.
and I'm thinking from a
I know
layperson
you're.
point of view. I don't know what an RPC node is, so I don't want this to get too technical. So, in very simple layperson's terms, what is an RPC node?
Once upon a time, it used to be what a wallet was, right? So when it was just Bitcoin running on Windows, everybody just ran a full node, and that was your wallet.
Right.
And I think that's kind of the original design intention of the way these things are designed, because it's sort of a limiting factor. But in short, an RPC node is how you get data from the chain.
Okay.
And the miners and validators typically, well, they could in theory provide that, but they don't really have an incentive to provide it. And so on Bitcoin, they call them full nodes, and every other chain they're called RPC nodes, but they're essentially the same thing. And they can be run by volunteers, or they can be run by the dApps, like in this case here.
Understood.
Is that right, Freaknik?
Yep.
Anything
No, I can
I'm
get it.
missing?
Yeah. So yeah, it's just a way to talk to the blockchain. Yeah.
Right. Anything else, Clayton?
No, I was just going to say the reason I'm digging in this direction is because one way to understand proof of performance is that you're sort of depinning the RPC node and you're building that directly into the consensus, right? So I've thought a lot about this problem of how do you measure RPCs and reward people for providing that service. Now, for something like a DVPN, I'm not sure how you would do that, but the nice thing about RPC service is that you're only serving data that comes from on chain, and so there's some amount of knowledge about what the answer should be, right? If you ask me what your balance is, and I'm running a Cosmos node, there's only one correct answer, right? Or at a certain tip of the chain, right? There's one correct answer, and so if I tell you something and it's wrong and I sign it, then you can slash me. So we sort of abuse that mechanism for two of the things that we do, which are the data runners and the transaction runners, also the block runners. But anytime data is coming out of the chain, it's sort of there's a known correct value that's supposed to be returned, and we sign it along with that. But that only works for consensus data. It's harder. I'm always curious how DeepIn projects work because you can't trust the provider necessarily to say, "Oh, I was up the whole time," right? But you can't exactly trust someone to police them either, because they might also lie, especially if it's in their interest to lie, right? If I'm buying service from someone and I can get my money back by lying and saying I didn't get the service, then that wouldn't work, right? So but a common theme, this is maybe interesting, is that you are typically empowering the users to have some kind of a vote, right? The vote in the case of our consensus is sort of comes in the form of a payment, which is the fee, which is the difficulty. But in the case of something like this DeepIn project, it's like literally a vote on reputation of the nodes. But the cool thing about it is you're empowering the end users, right? They're the arbiters ultimately of what is valuable in a decentralized network or any decentralized application, right? Bitcoin is valuable because the people believe it's valuable. Yeah. It's secure because it's valuable. So that's the beauty of all this stuff.
Okay.
Yeah. So would that be? I was going to ask. So is that like so your proof of performance consensus mechanism is based off of incentivizing RPCs or signing transactions and validating correct information? Is that correct?
Yeah, that's exactly right. The whole design philosophy from the beginning was we need to pay for every RPC, and how do you do that? And there's sort of two mechanisms you can think of. One is like when data flows out and it's going to ultimately be used in a transaction, then that data has to be included when the transaction is sent back in, and they flow through something called transaction runners, which I'm not going to get into right now. But at that point, the data is validated and it's considered like legitimate participation in the block production if you were someone who sent data to a wallet that ultimately ends up sending a transaction back into that block. But that doesn't cover everything, unfortunately. So we do have another mechanism which we call data for the data runners, and we call it the lucky hash transaction. And in that case, we sort of just reward randomly, almost through a difficult hash sort of a system, but it's not, you can't just guess hashes. You're given a limited number of hashes per block as a wallet. And then somebody gets a random reward that we call the lucky hash. And they can then, they're then required to request data from a data runner, and they combine those two things, the lucky hash and the data, and then they can get a reward that rewards both of the players, so the data runner and the wallet. And data runners don't necessarily know who's lucky and who's just asking for data. So that's sort of how that mechanism works. That mechanism could actually be, yeah, go ahead.
Do you have so it's a triage of consensus mechanisms, like data runners, transaction runners, and RPC?
Yeah, you can kind of think of that way. Yeah. The block runners and the transaction runners are just the block producers, actually, and we kind of just split it into two. And the main reason for that is to incentivize block propagation. Because a weird thing about, like, if you think about Bitcoin is like, I could send, like, let's say all three of us are miners, right? And, or I'm a wallet, right? And I send you a transaction and then you give it to Rich and he mines it and takes the reward. Well, you kind of participated in a sense into that block production, and maybe you deserve some reward, right? Especially if you're trying to think about RPCs, like you did a lot of the work if we're just focusing on RPCs. So we kind of just split it out. So in that case, you would this is not a great analogy, but you'd sort of be the transaction runner in that case, and he'd be the block runner, right? So you're propagating transactions and propagating blocks. He wants to send you a block in order for you to send him the transaction. So there's like a win-win, a consensus amongst the block runners and the transaction runners in that case to just move data around more.
So is it a weighted consensus between the three? Is it like the block?
Yeah.
So it's weighted a little heavier.
We don't actually have the final numbers on that yet because we're going to figure that out in phase 2 of the testnet, like depending
Okay.
on what the load looks like. So if the data runners are, typically suffering 60% of the cost of like the whole network, then they're going to get 60% of the reward.
Okay.
But we got to
Yeah.
measure
Okay.
that
So
to know what it's going to be.
that's good. Yeah. That makes sense.
Okay. Now, Clayton, what are the advantages of lithium? I mean, we've got so many layer ones. Do we need another one? And why is this one better
This
than
is the
all the
last
others?
one.
This is the last one.
Yeah.
The layer one to
Yeah.
end all at layer ones.
Right.
Future proof as well.
Right. Well, that's the ambition. It's, to me, this is a big problem because you have a lot of things suffering because of the lack of scale, and most of the people kind of perceive that as the gas costs, right? So you can think of it that way, but you end up compromising in a lot of ways. Like Freaknik here was just saying they update every 30 seconds, and I was asking, well, why not every second, right? And the obvious answer is like it's on-chain data. You have to think carefully about how to use that and whether it's really worth it for the end users. Like, how often do they really need that data to be on-chain? And if the cost is significantly higher, then obviously you have to sort of compromise there, right? But if you can push the cost a lot lower, then you can open up a lot more possibilities for getting stuff on chain that maybe it would be nice to have on chain, but it's not like as critical as like a DeFi swap or pushing your liquidity around and stuff. Like, obviously those things are sort of pricing everything else out now.
Okay, but for the end user and for applications, what's the point of Lithium One? I mean, what are the advantages?
Well, you can get more on chain, right? So if you want to say, put your social network on chain, just as one dumb example, right? Or not dumb example, maybe it's important to some people, but just one example would be, you could put your friend graph on chain, and then you could maybe secure it through some privacy tools, and then also leverage it as, sort of a data sovereignty sort of a situation where you only let people have access when you want them to have access, right? So you get to control the data, but we haven't really seen anything like that because it's just not really realistic to build that in a decentralized way with the current infrastructure. So stuff like that, I think you open up a lot of possibilities there. It's hard to say like where it all ends up, right? It's a bit like we've got a new iPhone. Okay, like what are we going to do with this, right? Like, in the first year of iPhone, you had a bunch of silly apps, but like obviously having a mobile internet experience really changed the way people do things, but it's still hard to predict just because you have an iPhone in your hand in whenever that was, 2005 or whatever. It's not really clear how people are going to use it exactly, but we just believe that it's going to open up a lot of possibilities.
Okay. Freaknik?
Yeah, no, I like the consensus mechanism. It's completely unique in the space. Like when I was reading about it last night, I think it incentivizes a lot of users to actively participate in the network more so than other blockchains I've come across. And so the more active participation you have will draw more attention to app development, right? Because they'll be like, well, the monthly active
That's the
users on
plan.
this chain is higher than a third of the rest of the blockchain. So let's develop on Lithium instead of XYZ.
Yeah.
So I think
That's one thing about markets.
that's
Is everybody wants to be at the biggest one. I mean, it's also a
yeah.
challenge, right? When you're a latecomer, it's 2025, and the layer one game is a bit played out. So that's a big challenge for us. But we do believe it can ultimately be, the place to go because everyone's there, right? It also gets more secure as it scales. So that's sort of the really beautiful thing about it, right? It's because everybody has this idea that scale and decentralization go against each other, which is true when you have the RPC nodes, right? Because if Cosmos, for example, were to 10x the size of the chain to accommodate more, your RPC cost for those 20 nodes you were mentioning would also 10x. But your user base didn't necessarily 10x because
and maybe your server doesn't have the bandwidth. Sorry.
Yeah. So in a sense, like when you're running an RPC node as a dApp, it's kind of funny to think about like if the chain only has like 3 dApps, it's not that bad because you're synchronizing all this data for like, if you're Uniswap, you've got like the Aave data and whatever else, right? But it's not that much, because your user base is like a significant part of the chain itself. But if you're on a Solana where there's like 1,000 dApps, maybe you've got to do like 1,000 times more work just to service your 0.1% of the community that's using your dApp. So you have like the RPC cost sort of as a roadblock to all that stuff, right? And obviously, like as someone who needs to run an RPC node, you would be probably upset if like you've designed the app in a way where it works with the current RPC costs and the current consensus and gas costs and all that. And then the foundation goes and says, "Oh, we're just going to 10x your costs now, right?" But you're like, "Oh, but I designed it with this 30-second time, based on the current situation, right?" And this is sort of why I think you see all the infighting in Bitcoin when when they talk about anything, even if it's not really changing the consensus. There's sort of a bit of a freak out by some of the community, right?
Okay. Freaknik, anything else?
Not that I can think of off the top of my head. Just it's an interesting project, and I'd like to see how it. I'd like to play with it eventually, and so I definitely keep in contact, Clayton, and maybe we can work some kind of hybrid solution where we garner support from each of our networks.
Yeah, that would be good.
Yeah, that'd be awesome. Like I said, we're super keen on the whole PKI stuff. I mean, this is like why I'm really in the space, right? Is the sovereignty and the privacy and stuff. So
I agree.
That'd be awesome. I know you guys are Cosmos, so it might be a tricky integration. We're EVM compatible, so we're mostly focusing on the. Well, that's why we're going to ECC in 3 weeks, because we're the Solidity developers.
The Cosmos, the Interchain Foundation actually has it's called Eureka. So we can transfer coins native on Cosmos to Ethereum or EVM compatible chains. So it uses, I don't know if you're familiar with Cosmos, but we have IBC, the interconnected blockchains. So it allows you to talk to any other app chain on Cosmos and send coins back and forth. And they're native assets. They're not even tokens. They're native assets on the chain. So like if I send our coin P2P to like Atom, it becomes a native asset on Atom, and it removes the actual quantity of coin on Sentinel. So you can do that. You can send it through IBC Eureka to EVM compatible chains as well. That just rolled out within the last month. So so that could be a way to between our blockchains to talk. Yeah.
Okay.
And just on that, let me break it down for people who are watching or aren't. PKI is private key interchange. So instead of using passwords, it's about swapping and using private keys to access private data. And then Cosmos IBC inter-blockchain communication is a particular protocol that allows the Cosmos asset chains to talk to each other. So you can have blockchains talking to each other that use that framework, compared to EVM, which is Ethereum virtual machines, which are protocols or blockchains that can pretty much just run on the Ethereum blockchain. So we're talking about Near, we're talking about Binance Smart Chain, that's EVM compatible, but also some of the Cosmos IBC are EVM compatible. And I can't think of any right now, but apart from ones that have gone a bit defunct, like Evmos is IVM.
Yeah, that kind of went down the drain for
but DIM Dimension is EVM compatible on the part of the Cosmos protocol. There's also Polygon is EVM compatible. That's on Polygon. That's on the Ethereum blockchain. So Lithium is EVM compatible, but there are ways where different chains can communicate with each other, including some of the decentralized, the DEXs within the Cosmos.
Yeah, sometimes bridges and DEXs sort of blur the lines there a bit, right?
Yeah, well, Polaris, which is an Osmosis DEX, which is Osmosis is part of the Cosmos ecosystem. Osmo is the token. They're trialing a multi-chain decentralized exchange. So you can go from native Bitcoin to Atom to Ethereum to Osmo and so on. And then there's skip.go.
That allows interchain swapping. That's really pretty interesting. Skip is pretty interesting project.
Yeah, so there are projects like that, and I've been in the Cosmos ecosystem. I think the first Cosmos asset I ever got was either Secret Network or DVPN in 2018.
Actually, Secret was the first one I got. I actually was on Secret before they linked IBC to the Cosmos ecosystem. So I was so Secret, and then shortly after I was like, that's when Secret joined Cosmos. I was like, oh wow, look at this whole huge ecosystem. So that's when I discovered Sentinel back in late 2021, and I've been with them ever since. So
right, and Clayton just showed his little privacy baseball cap, because all about privacy.
I think that was their merch from Bangkok, if I remember right.
All right.
It's definitely their event. I'm pretty sure it's their merch.
Right.
I have their token here too. I keep fiddly stuff on my desk for when I'm compiling, but I've got their little poker chip here. We could plug secret. I don't know. Is that going to focus?
Oh, cool. Oh, awesome.
Secret of
They're giving these out. There's a QR code on the back.
Yes.
Oh, very nice.
That's just when I'm compiling code, I can fiddle around.
Yeah.
Very good. And I know both of you, well, you both said you listen to some of my political videos that I do, and I do far too much political coverage. I need to do more crypto. But one of the things I want to let you know, warn you about, actually it doesn't really apply to you because you guys aren't in Europe, right? But the European Union are going to ban privacy cryptos.
Yeah.
Good luck. Good luck with that.
Yeah, you can't really ban it because there's no way it's like shutting it down. But you can deter
be hard
the
to run a
public from
node.
using them. Yeah.
Right.
Oh,
Well, that's why you need the DVPN, right?
That's right.
Yeah,
You need
exactly.
a DVPN, pirate chain, secret network. Very good. Okay. And just on that, does lithium's it's a public blockchain, but what's the potential for developing private assets or dApps on it?
Yeah, well, we're very keen. I mean, our bread and butter is the consensus, right? It's proof of performance. And the way I see it is, the privacy stuff is sort of feature level. So it's stuff that we want to bake in maybe post mainnet. Mm-hmm. I'm also playing a wait and see game with the VM game right now. So there's Soda Labs is a very cool project. They're doing a garbled circuit VM. I learned about this from the Secret Network guys, by the way. Garbled circuits are very cool. They're not, everybody's talking about the fully homomorphic encryption and the ZK stuff, but garbled circuits is another sort of sleeping giant, I think.
Oh, I haven't heard that.
It's cool stuff. You have to pre-bake some of the computation, so it's a little more upfront cost, but it's cheaper than ZKs. That's what I'm being told. But anyway, they're developing a GC EVM that's a fork of Geth. Now we're Rust-based, so we're using our EVM, and so I'm waiting for somebody smart to come along and make the either ZK EVM or GC EVM with Rust-based, hopefully a fork of our EVM. But I haven't seen that yet. But hopefully someone else does that work, and we can just take that benefit from them and deliver that to people. The other thing is you can always do privacy at the sort of in layer 2, right? So there's nothing stopping people from doing privacy in smart contracts other than it's really expensive. And so you can also deliver some solutions that way as well. So we'll see where we get to. But obviously I'm very keen to get that stuff done. But like I said, our focus has to be on the proof of performance and getting that stuff out the door first, and then we'll do the other stuff later.
Great. Very
good. Easier if we do it before mainnet. So everybody else still asks me when mainnet, and they want it to be sooner. But if we roll out the privacy features pre-mainnet, then obviously they could be stronger, right? Because then you don't have this sort of ZK cache thing where it's half the stuff is private and half the stuff isn't, and there's potential leakage issues there. But we'll see what we can do. Hopefully we can solve all these problems.
Very good, very good. And I just going to say there was far too many mnemonics there. So
ZK, zero knowledge. FHE is fully homomorphic encryption. And that's another sort of...
Cryptos use fully homomorphic encryption?
Dero did. They I don't know if you're familiar with the Dero blockchain, but they had it. But there was actually a break in their knots. They reused the randomness for their knots, and so actually de-anonymized their whole chain. So
wow.
Somebody was doing an FHEVM. Zama, ZAMA. They're doing FHEVM.
Right. Okay, an EVM in Ethereum virtual machine, and the other one garbled.
Right.
Something transaction.
Garbled circuits. Just
a whole new privacy protocol that is just fresh off.
I'm gonna have to look that one up. I haven't even heard that one. I'm gonna have to research that one later today.
Now, where can people find you both?
So you can go
on lithium.com. Go ahead.
Go ahead.
Sorry.
You go first, Clayton. Sorry. Go ahead.
Yeah, lithium.com. You can find our Telegram and our Twitter there. Those are our main channels. We have a Discord as well. I know some people like to jump in there. But LITHEUM. So it's it's got the E for the EVM.
Great.
Oh, that's where that came from. Okay. All right. Now it makes sense.
Pricknick?
You can go for the main blockchain, it's sentinel.co, and then for us, it's mathnodes.com.
Yes, and I would urge anybody and everybody who's watching, check out both these projects, and you have to go to sentinel.co. You go to downloads, you can find all the different DVPN applications that you can use. You can use them on Mac, you can use them on Linux, on Windows, on on Android, on iOS, and some of them are free, and the ones that aren't free are really, really cheap and affordable and very robust, and they keep your data private and secure. Freaknik, Clayton, thank you so much. Look forward to having you guys on again at some point. And between now and when I see you next, please keep filling your pockets with freedom. This is Crypto Rich and Crypto Clayton and Crypto Freaknik signing out. All the best. Bye-bye.